In this video, we're going to be talking about finding something called a reference angle. And a reference angle, as you can see written up here, is an acute angle formed by the terminal side of the angle and the x-axis. And I went ahead and even made a little note right over here. In this definition, we're looking for an angle, acute, so it's between 0 and 90 degrees. And we want one of the sides of our angle to always be on the x-axis. For right now, in Algebra 2, it's kind of like, why are we doing this? It's just a random thing to have to do. But when you get to pre-calculus, when you talk about trigonometry, it's going to be really helpful to have one of those sides along the x-axis. So it's kind of setting things up for later down the road for you. But the important point, the thing that you definitely want to make sure you make note of, we're looking for an angle that has a side on the x-axis. That's going to be important. And I'm going to show you 4 examples of this, one in each quadrant, because the different quadrants kind of have their own little quirks to them. So, first thing I'm going to do is look at the first quadrant, and I'll make up an angle right here. Let's say I had an angle like this that was 70 degrees. So, there are 2 pieces to being a reference angle. You first need to be an acute angle. Our angle is 70 degrees, it's already acute, that's good. The other thing is that it needs to have a side along the x-axis. Well, that yellow side right there on our angle, that yellow ray, is already along the x-axis. That's good. This angle is a reference angle by itself because it has our side along the x-axis. So 70 degrees is the reference angle. So the reference angle in this one is going to be 70 degrees. So that's our reference angle, and that's really all we have to do. In quadrant 1, the angles are always actually going to be their own reference angle. So angles are always their own reference angle. So that quadrant isn't all that exciting, because it's really just repeating the angle that you already have. Let's look at an example now, though, where we are in a different quadrant. So let's take an example in quadrant 2. Suppose I have an angle, but this time my angle is going to be in our second quadrant. And let's say my angle is 140 degrees. And I want to find the reference angle. So, the 2 things I need to have to be a reference angle. First of all, I need to make sure that my angle is acute. Right there you can see I have a problem, because I have a 140 degree angle. That's not acute. The second thing is that I have to have a side on the x-axis. I do have that, but it's not acute. So it's not going to be our angle. So what I need to do right now, I'm looking at my picture. I need a way that I'd be able to distinguish this angle were I to look at my picture. I know I was talking about that same situation. If you notice this little angle over here, this would make a really nice reference angle in yellow because it's acute and it has a side along the x-axis. If I knew that yellow angle, I could figure out the 140 by doing 180 minus that. So that would be a good angle to have. And it turns out if that's 140, that little angle by itself is a 40 degree angle. Thinking back to geometry, they have to add up to 180. So my reference angle on this problem is going to be 40 degrees. It's that angle right there, less than 180, sorry, less than 90, it's an acute angle, and one of the sides is along the x-axis. So that's how you handle the second quadrant. In the third quadrant, suppose we had an angle like, in this one, say my angle was 260 degrees. And again, I'm looking for my reference angle right here. So 260 degrees to get to there. Reference angle, I have 2 things, and in this one, again, I'm not acute. I need to do something about it. Most kids, like the very most common mistake I will see, kids will be like, oh, this will make a good reference angle right there. It's acute, it's right there, you can see what's going on. Unfortunately, though, that is not a reference angle because it doesn't have a side along the x-axis. What I actually have to use, that x-axis piece is important. My reference angle in this one is actually going to be this yellow guy. Oops, redraw that line. This yellow guy right here. It's less than 90 degrees, it's acute, and it has a side on the x-axis. Well, if I go from here to here, and that's 180, that's going to make this an 80-degree angle. So my reference angle in this problem is going to be 80 degrees. And I'll show you one more example here in quadrant 4 this time. For quadrant 4, suppose I had a 330-degree angle. You know what? Actually, I'm going to do it. Let's do something a little different. Let's do a negative 15-degree angle. So this from here to here is going to be negative 15 degrees. There's nothing that says you have to go in the same direction, or you can wrap around, you can do all those different things. So negative 15-degree angle. If we're looking at this right here, it's actually really close to a reference angle. It's got the side, and it's an acute angle, but it's negative 15 degrees because we're going in that direction. The angle itself, though, picture if you were back in geometry again, you guys would just call that a 15-degree angle. So my reference angle is 15 degrees. It's got the two characteristics that we want. If I were to have gone the other way on this one, you would call that a 345-degree angle. And it'd be the same thing. You want to have a side of the x-axis. The yellow angle would still be my reference angle, and it's still 15 degrees.